Alright, what's up, garam? Welcome to Elijah's kinematics lesson. So, today we're going to be taking a look at these four formulas. Now, the one that you sent me is this one here. But in kinematics, this formula is usually accompanied by these formulas. I don't know if you've been given all of these formulas or if you're going to be given these on the test, but these are either going to be something you memorize or something you're going to have to know very well. And the thing is, you can actually derive all of these equations from each other. So like, for example, take a look at this one here, or like three of them I think are derivable from each other, and then one is like separate. But you'll see this one at the top, number one, is like after you take the derivative, you'll get number three, right? If you do it according to time. Or not derivative, integral rather. So you'll see that these equations are kind of connected. Now, in kinematics questions, the way you should be looking at the questions, like the magic trick with these types of problems, is, I'll put it in a box here. Let me make a box 1 second. Okay, so you're going to be given like a certain amount of pieces to the puzzle, and you're going to be missing one piece. And so if we take a look at these equations, we see that there's a few possible pieces. For example, one of them is delta x. We have v, VO, t. I think TO will be on here, right? Oh no, it doesn't look like it. Okay. We have A. Is that it? Okay, looks like that's it. So we have delta x, which is, distance or change in distance traveled. V, which is like sort of final velocity or ending velocity. VO, which is initial velocity. In our physics, we would put a 1 here to sort of signify that better. T is time, obviously, and A is acceleration. So, so these questions, they're going to be giving you, for example, they'll give you the delta x, VO, T, and they'll say, figure out the A. And so the magic trick in these types of questions is to look at one of these formulas that only contains the parts that are being asked about, right? Even if it's given or it's the missing one. If V1 is not a part of the problem, you don't want an equation that contains V1. And so what we'll do next is look for an equation that has these. So I need one that doesn't have V, let's see, but has VO. Okay, so it looks like 3 is the only one that satisfies that. Does it have delta x? Yes. Does it have VO? Yes. T? Yes. Has it twice even. And does it have A? Yes. So number 3, question 3 is going to be, or formula 3 is going to be the formula that we use. And so let me write it out like this. Oh, okay, I am recording. Oh, thank goodness, I thought I wasn't recording. Okay. So we got this going right here. Now, you'll notice the missing puzzle piece is A, right? A is all the way over here. And so all we really have to do is solve for A, or solve the formula for A. And in physics, something that I always suggest is never plug in numbers. Like, you never want to plug in numbers here because it's just gonna be like cringe. Like, you could write on the side delta x equals, da 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 da, VO equals da 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 da, T equals da 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 da, and you could even write A equals question mark to remind yourself, And so I'll solve this for A. We'll go delta x minus VOT equals 1/2 AT. And then I'll times both sides by 2 to get AT squared. And then I'll divide both sides by T squared to solve for A. And then at this point of the problem, all you need to do is you're given delta x, you're given VO, you're given T, you're given T squared. I hope you know what 2 is. And then you plug it into a calculator. Boom. You have the acceleration. So, yeah, one thing about the plugging in, this is the point in which you would plug in. Only when you're at the last step where you have the variable that you're solving for, then you plug everything in. So that was obviously like a general case. So let's go ahead and do a real example, like a real problem. All right. So I just found the problem online. It's a pretty easy one. And then I might do a harder one just for the fun of it, because you're going to be learning about something soon, or doing certain types of problems soon, and so it's going to come up, so might as well do it right now, right? Sorry, I'm just trying to import the problem. Open URL, copy image, paste. There we go. Okay, here's our problem. A stone is thrown vertically upward with an initial speed of 5 meters per second. What is the velocity of the stone 3 seconds later? Alright, so I don't know if you learned about dot diagrams yet, but this is something Mr. McKinnell taught us, is always helpful. So just draw a dot for the object in which the forces are acting upon. And in this case, force is acceleration. I don't know if you learned about any of that, but our only force is the acceleration of gravity. So I'm just going to use the number 10 because why not, right? It's easy. And then let's do negative 10 for downward. Let's give it a direction. And it has an initial velocity upwards of 5 meters per second. So first step, what I would do is write down the puzzle pieces that are giving to you. So we have initial velocity, 5 meters per second. We have acceleration, right, because it's constant, always gravity, negative 10. And then, let's see, we have time. The way to see when it's asking what is the velocity 3 seconds later, think of it as it's giving you the time. It's saying 3 seconds is the time that you're solving for. And then all we need is final velocity. So I'm going to do v1 equals question mark. Alright, so let's go and take a look at our puzzle pieces box. I'm given VO, A, and T, and what I'm solving for is v1. So what I need to do is find a formula that does not include delta x. If delta x is in the formula, then I can't solve it because it's just another variable. We don't want that. So I need the formula that has only these variables. Alright, which one doesn't have delta x? Wow, number 1. Alright. So I'm going to write our formula number 1 right here. And the next step, let's solve this problem for the thing that we need. Holy moly, it already is. Wow. Alright, so all we need to do next is plug in numbers. We have a v1 equals VO, initial velocity. Remember we set upwards as our positive direction, so this would be a positive 5 plus. we have a acceleration of -10 and a time of 3. So, in 3 seconds, we are looking at a velocity of -25 meters per second. Now, that sounds a little off, just intuitively, but 1 Mississippi, 2 Mississippi, 3 Mississippi. I guess that's long enough for a rock to fall back down, right? I don't know. Anyway, this is correct because this is the equation. Oh yeah, I guess this is not a nonsensical question. So, this would be the answer. Not too bad. Pretty easy if you ask me. Alright, so let's take a look at a harder problem that includes an element that you'll be using soon. It's not going to be harder in the physics, only in there's one trick to it. So let me go ahead and find my question. And I'm just going to go ahead and try and see if that answer was right. Submit. Number 9. Yeah, okay, so -25 was right according to this website. Nice. Let's freaking go. That's crazy. Okay, I found a nice little problem that includes some different elements, even more than what I thought we could get into here. So let me go ahead and open URL, copy image. Okay, so our problem. A soccer ball at rest on the ground is kicked with an initial velocity of 10 meters per second at a launch angle of 30 degrees. Calculate its total flight time, assuming that air resistance is negligible. So let's take a look at this question here. What is it asking us? So let's go ahead and draw a ball with an initial velocity of 10 meters per second and is being launched or whatever at an angle of 30 degrees. So this question obviously is a bit more complicated than the last one, because one thing is we have this degree, and the second thing is there's an element of mystery to the question, because you'll see that a soccer ball at rest on the ground is kicked with an initial velocity of 10 meters per second. So we have VO, and we have well, I mean, we know acceleration because gravity, but that's really all that we're giving. And then we're meant to solve for t. You'll notice there isn't an equation that only has these 3 variables. So what do we do? How do we solve this type of problem? Now, something to keep in mind with these type of gravity problems. This is called a 2D projectile motion problem. There's a lot of symmetry involved. So the path that this ball is going to take is like this. And what it's asking us is, how long does it take to get here? Right? Because this is where the ground is. If there wasn't ground here, it would keep going, you know. But there's the ground here, so calculate total flight time. Touches the ground right here. So this is actually very helpful, because something that's very important about these types of problems is that the velocity of the ball here is the same as the velocity of the ball here. Now, if the velocity here was different, it this velocity obviously would be different, but the thing that changes is how far this, range of motion goes, right? It goes like this, It doesn't change the fact that the velocity here is the same as the velocity here. At these points, in whichever one of these paths, the velocity is always same at the start and over here at this symmetrical equal point. So what this means for us is that V1 equals negative VO. Am I right? Obviously this isn't the case when we're looking at the velocity as a whole, because one of the velocity vectors looks like this. The second one looks like this, right? This vector isn't the negative of this. However, another special thing about these types of problems is we usually only need either the vertical velocity or the horizontal. For example, it could have asked us, what's the distance that it travels when it touches the ground, right? In which case, we would only really care about, we would need to find the time, which we would find using the vertical velocity. And using that time that we found using the vertical velocity, we would then find the horizontal velocity, because you only need one of these at a time. And for this question, which one of these do we need? Well, we know the ball is going to go up, the ball is going to go down, and hit the ground. And so it doesn't ask us anything about distance traveled or anything like that, so we're not going to need the horizontal at all, the horizontal velocity. So we have V1, I'll call it horizontal, equals V0 horizontal. And this is the trick that will help you solve this question. Because now we have V1, we have VO, we have A, and we're solving for T. And there is a formula that contains all of those. So how do we actually know the value of V1H and VOH? Well, oh, sorry, there's a negative sign missing here. Well, we know the velocity of the ball kicked at an angle is 10 meters per second. We have our angle like this, 30 degrees. And I'm going to go ahead and draw a little triangle like this. And to find the horizontal portion of the velocity, now you can add two vectors, or not add, but combine two, horizontal, or no, it is add. You can add a horizontal and a vertical vector to create this hypotenuse, right? Or, I don't know if add is the correct, but you can combine, whatever. And the way it combines is, let me write x and y. X will equal simple trigonometry. Hypotenuse times cosine of the angle, right? And y, horizontal velocity, which is what we actually need right here, so let me delete this last bit. Y, which equals, we'll call it VOH, since we'll say upwards is positive, which equals negative V1H yeah, because the V1 is going to be negative, so this negative will cancel it out, right, to make it equal. We'll equal this, will equal 10 meters per second times sine of 30. Boom. All of a sudden, we have V1H, or sorry, VOH. We know that V1H is negative this, and now we can solve, because we have everything. A equals negative 10, T equals question mark. So once again, we're looking for the formula that doesn't have delta x, which is formula 1. So we have V equals VO plus AT. This time we are solving for t, so we have V minus VO over, and at this point you can even say, for example, VO equals negative V. Or sorry. Yeah, well, we can say that. That's right too. So what you can do is you can actually plug that in straight away. So let's go ahead and cancel out this negative, take away this O, and then this V plus V, boom, 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 boom. Now let's do it all in, not in one step to make it not confusing. So V minus VO equals AT. Now at this point, let's go ahead and do that plug-in. So V plus V equals AT, and we will go 2V over A equals T. Remember how you don't want to plug in? Because imagine you had all this garbage plugged in right now twice. How cringe would that be? Okay, so at this point we know what our V is. Remember, V is negative all of this. A is negative 10. So you'll just plug everything in. So I'm going to go ahead and go for an online calculator. I have negative 20 times sine of 30 degrees. Sine of 30 degrees is 0.5. So let's plug these in. Let's not be cringe. Let's not be cringe, shall we? I have 2 times negative 10 times, you can sort of forget about the units. I mean, you can keep them in because they'll sort of help you not make mistakes, because the units will have to cancel out. But it's just sort of like an extra added long step, you know what I mean? So we have 2 times minus 10 times sine of 30 over negative 10 equals the total time traveled. And so let me go ahead and plug this into a calculator. I have 0.5 times negative 10 is negative 5. 2 times negative 5 is negative 10. Negative 10 over negative 10 is 1. So we are looking at a total of 1 second. And that is one of the answers. I assume that is correct. Now, the crazy part about all of this is if you were to actually set this up in real life, air resistance is actually pretty much negligible, and the real time that you would measure would be very close to 1 second. You know, it might be, it would probably be in the air, let's see, it might be in the air longer because it would generate lift. So you might have like 1.05 or 1.00, even 00 maybe. Maybe not actually. But you know what I'm saying is you're actually solving real life problems that you can replicate yourself and experimentally figure out yourself and figure out that this is the correct time. So if you want to, you can do a marble rolling on a table exercise, figure out using all of this, you know, the same techniques that we've been using. For example, in the marble, let's set up the marble experiment. You have a table like this, you have a ramp, and a marble going like this, right? The marble is at the top of this ramp and it's dropped, and your objective is to place the cup so that the marble will fall in it. And ideally, Like in this experiment, you're only given one chance, so you either get it on the first try or you don't. And so, how you would solve this problem is you would, so the way you should think about it is you want to think about how long will the marble take to, from V0, we're looking at vertical V, V0 equals 0 meters per second downwards. We have the height of the table, right? So if we have a delta x of height of the table, what's going to be our t? So we have delta x, we have t, or sorry, we don't have t. We have delta x, we have a, we have v0, which is 0, and we're trying to solve for t. And so once you solve for t, next step would be to look at the horizontal velocity and find, in that amount of t, how much will the velocity go forward? Or how much will the velocity of the marble cause it to move, right? So essentially what you're doing is finding how long it's going to take to fall by looking at the vertical aspect, and then all you're doing then is calculating the speed of the marble by timing the distance it's going to, or like timing the time it takes to go this distance with the distance, so you can find velocity. And all you have to do at that point is times velocity by the time that you already found to get the delta x. Right, that's just like a simple, like if you traveled 1 hour at 60 miles an hour, you would go 60 miles, easy. And so in the same way, you calculate the time using the vertical aspect of the acceleration and the delta x, and then you multiply that time by the velocity that you solve. That's how you would place the cup to catch the marble.